Okay, yes. Previously, we were talking about multiplication and division, both sides of an inequality, and how multiplying or dividing by a negative will reverse the inequality sign, because negative also means opposite in mathematics. So the opposite of greater than is less than, the opposite of less than or equal is greater than or equal, and so forth. So the answers to page 106, so you can check your work. On page 106, 3 divided by negative 1/2 is negative 6. 6 divided by 1/2 is negative 12, and negative 6 is greater than negative 12. And I've also marked it on my number line. Negative 6, negative 12, and again, this side of the number line indicates increasing values. Going this direction on the number line, decreasing values. They're getting smaller. Problem 1E, when you divide both sides, you divide 3 divided by negative 2, 6 divided by negative 2, you end up with negative 1/2 and negative 3. Negative 1/2 is larger than negative 3. So again, the inequality sign flipped, it reversed when we divided by a negative. Problem 1F, we're dividing by a negative 3. 3 divided by negative 3 is negative 1. 6 divided by negative 3 is negative 2. And negative 1 is greater than negative 2. When you multiply or divide each side of an inequality by the same negative number, the inequality sign reverses direction. And that's really what we've been working on. And that's a subtle rule in working with inequalities, but that's the rule that puts it all into place so you can work on solving any inequality now. Page 107 compares Brendan and Jenna and their solutions to negative 4x less than 20. Brendan divides both sides by negative 4, and he put x less than negative 5. We test his solution, or we test some of his solutions. It just asks us to pick 3. I chose negative 6, negative 7, negative 8. I could have chosen any number smaller than negative 5. And when I put negative 6 in, negative 4 times negative 6, positive 24. And is that less than 20? No. So negative 6 is not a solution. We try negative 7, negative 4 times negative 7, positive 28. Is 28 less than 20? No. So negative 7 is not a solution. I tried negative 8, negative 4 times negative 8. Is that less than 20? Negative 4 times negative 8 is positive 32. And that is not less than 20. So that's not a solution. So Brendan has a mistake in his. Jenna divides both sides by negative 4, and since she divided both sides by negative 4, she reversed the inequality sign, which is what we're supposed to do. So it says choose 3 values to test Jenna's solution. I chose negative 2, negative 1, and 0. Again, I could choose any number greater than negative 5. I could choose positive numbers. Again, an unlimited number of numbers. When I substitute in negative 2 for x, negative 4 times negative 2, positive 8. That's less than 20. Negative 4 times negative 1 is positive 4. That's less than 20, so that's true. Negative 4 times 0 is 0, and that's less than 20, so that's true. So we should circle in the problem 3b, it says cross out the problem where they made a mistake. We would cross out Brendan's, and we would circle Jenna's. Jenna did it properly. Again, if you have any questions on this, please make sure you're emailing me, asking me, sending me text remind, but make sure that this is making sense. Page 108, number 4a. Again, we divide both sides by 8, positive 8, and we get x greater than 2. So any number greater than 2 should work. I tested it with 4, 5, and 6, and all 3 of them worked. 4b, x divided by 4 less than or equal to 4. I multiply both sides by 3. x less than or equal to 12. I chose three numbers less than or equal to 12. I chose 10, 11, and 12 since 12 is equal to 12, and all three of those worked. For C, I divided both sides by -5. I got x greater than -7, and I chose three numbers greater than -7. I chose -1, 0, +1. I substituted in those values for x, simplified, and found all three of them worked, so that was true. For D, x divided by -2 greater than or equal to 5. I multiplied both sides by -2. Again, I undid division with multiplication. And I got x is less than or equal to -10. So I chose three numbers less than or equal to -10. I chose -10, it's equal to -10. -12 is less than -10. -14 is less than -10. I substituted in those values and found that all three produced true statements. On page 109, a word problem where Aaron is buying supplies for football. He wants the eye strips. I said let P be the number of packages of the eye strips. $4 per pack plus the $55 has to be less than $75 if he's going to keep it under $75 and get the cheaper shipping. And we want to find out how many packs he can buy. I subtracted 55 from both sides and got 4 times P less than 20. I divided both sides by +4, and P has to be less than 5. Well, they're probably not going to let you break apart a pack of eye strips, so you're probably going to have to buy the whole pack. And so you can either buy 0, 1, 2, 3, or 4 and stay under the $75, but you can't buy 5 or more. It has to be under 5. So Aaron can purchase 4 or less packs of eye strips. They ask on page 109, number 2, they ask us to list our steps, describe the steps as we solve. 3x minus 2 equals 7. I added 2 to both sides, property of equality. I got 3x equals 9. I undid multiplied by 3 by dividing both sides by 3. Division, property of equality. And I got x equals 3. If I want to solve that equation then and verify that that works, I can put 3, substitute it in back for x, and see if this really equals 7. 3 times 3 is 9, minus 2, does that equal 7? 9 minus 2 is 7, equals 7. True. So I feel confident that 3 is the solution. On page 110, it gives us an inequality and asks us to circle the values that it's true for and list 3 additional values. Well, I simplified it. I added 2 to both sides. I divided both sides by, I don't know why I divided, that shouldn't be a -3. That should just be a 3. Divide both sides by 3, and I got x is greater than or equal to 3. So I circled 3, 4, 5, 6, 7, and I just added 8, 9, 10. On 3b, they give us 3 times x greater than or equal to 9. I divided both sides by +3, and I have x greater than or equal to 3. Same solution set. On 3c, x greater than or equal to c, same solution set. The solutions for 3a, 3b, and 3c are all the same. On number 5, I happen to write the same 3 additional solutions to 3a, 3b, 3c, but I could have written any numbers greater than 3. So I used, the ones I wrote were 8, 9, and 10, and I did it on all 3. But I could have just as easily done 100, 200, 300, 1 million, 2 million, 3 million. Any number greater than 3, greater than or equal to 3 is a solution. 3.5 is a solution. 4.5 is a solution. 5.5 is a solution. So they can be fractions, decimals. It just has to be greater than or equal to 3. Number 6, problems 2 and 3 are basically the same. One is an equation, the other is an inequality in various stages of finding its solution. So the steps are the same for solving 2 and 3a. They both require the same basic operations to get their solutions. On page 111, Number 7, it says graph the solutions for this equation. And again, this is the same equation that we had, x greater than or equal to 3. So I graphed the solution set, x greater than or equal to 3. Solid circle because it can equal 3. Choose a value from a solution set and verify it's a solution. In this case, I just chose 100. And I substitute in 100 wherever there's an x. 3 times 100 minus 2. 300 minus 2, 298 greater than 7, or greater than or equal to 7, which is true. So 100 is a solution. Looking at Ella and Jeff's, describe the strategy that Ella used correctly. Ella multiplies both sides by -4 to eliminate the fraction, so she reverses the inequality sign. She adds 3 to both sides, then she divides both sides by 2, and she rewrites the improper fraction as a decimal. Jeff divides both sides by -4, but he forgets to reverse the inequality sign. If Jeff had correctly reversed the inequality sign, then he would have had the correct answer of x greater than -1, instead of the wrong answer, x less than -1. So again, he just failed to remember to reverse the inequality when he divided both sides by a negative number. Page 102, 10A, they're asking us to solve, show our work, and graph. So again, I subtracted a 5 from both sides. I divided both sides by a 2, got x less than -11, and I'm showing it on a graph. 10B, I'm subtracting 1 from both sides. I'm dividing both sides by a -8. Since I divided by a negative, I reversed the inequality sign, and I got -12 is greater than or equal to x. So x is less than or equal to -12, and that's what I graphed. On 10C, I thought I could be clever and get rid of the decimals by just multiplying both sides of the inequality by a 10. To turn them into whole numbers. It really didn't work out for me, but I tried. I multiplied both sides by 10 and got 65x minus 11 is greater than 69. That way I have whole numbers and not decimals. I added 11 to both sides, got 65 times x is greater than 80. Well, then I had to divide both sides by 65, and I got x is greater than 1.2. So it didn't help me out at the end because I had to go back to a decimal. And then graphing it, x is greater than 1.2. 1.2, 2/10 of greater than 1. So this is an approximation. It's going to be close to where it should be. On 10D, I got rid of this divided by 5, so I multiplied both sides by 5 right away. Then I add 3 to both sides, divide both sides by 2, and I got x is greater than 26.5, or 26.5 is less than x. And so I went to 26.5 on my number line, and x is greater than it. Hollow circle since it's not equal to 26.5. 10E, subtracted a 7 from both sides. Then I multiplied both sides by -1 and reversed the inequality sign. And I have -11 is less than or equal to x. And I graphed because my x is greater than -11. Page 113,